Here we're going to work a few example problems from Chapter 4, starting with Worksheet 4-1. Let's look at example or problem number 2. We're asked to find the y-intercepts, equation of the axis of symmetry, and the x-coordinate of the vertex. We're also asked to make a table of values, which includes the vertex, and we're supposed to use this information to graph the function. We'll start on my calculator. For my calculator, I'm going to be able to find my table of values. I'm going to be able to see the graph and locate the vertex. So from there, I should then be able to find A. I have the equation in y equals y1. From there I can look at my graph, get a general idea of what it looks like. I can also look at the table of values. I need the table of values to include the vertex. I arrow down. See that at that point I have symmetry in my y values, which means that 2, 0 is going to be my vertex. So I'll want to write this as my table of values. So now with my table of values, I can start to graph accurately my parabola. I'll first plot my points, draw a smooth curve through the points. So I've taken care of my table of values. I've taken care of the graph. It includes the vertex. The y-intercept would be 2, 0. No, I'm sorry. The y-intercept would be 0, 4. The x-coordinate of the vertex would be 2, 0. So the x-coordinate of the vertex would be 2. The axis of symmetry is going to run through the vertex. The axis of symmetry would be x equals 2. On questions 7 through 15, I'm asked to determine whether each function has a maximum or a minimum and find that value, and then state the domain and range of the function. We'll first look at problem number 8. The first thing I'm going to do is take this equation and plug it into y equals, into y1, and y equals on my calculator. So I plug the equation into y equals on the calculator, and I go to my graph. I notice that this graph is going to be opening upward. And if it opens upward, then that means the vertex is going to be down here. That means it has a minimum value. But since it's going to continue to grow forever up, it will not have a maximum. So if it opens up, like this one does, and grows up, then it'll have a minimum but no maximum. If it opens down, it'll have a maximum but no minimum. That minimum value at the vertex would be at -2, -9. So the minimum value would be -2, -9. So for number 8, it has a minimum at -2, -9, and the domain for most of these parabolas is going to be all real numbers. The range is going to be the set of all y values greater than or equal to -9. If I look at number 15, and choose 15 because it has a negative, coefficient on the x squared. Again, once I get it in the calculator, take a look at the graph. The screen is not quite showing everything, so I'm going to zoom out a little bit. Zoom 3, hit enter. There's my parabola, so I see that it opens down this time. So that means that the vertex will be here. That means it will be a maximum. And I'm going to see the coordinate of that point is going to be, go to my table, arrow down. Look at the y values, continue to grow until I get to 15. Growing, growing, growing. I hit 15 and they start decreasing again. So 15 is that maximum value. So that's its vertex at the point 215. So this equation will have a maximum at 215. Domain, so they're all real numbers. The range is going to be all y values less than or equal to 15.